Right. So, hi everyone. I'm glad that so many people came. So you seem interested in the UMA technology, and yeah, it will be a great pleasure to talk to you about some of the concepts that we've been working on in the UMA work group. Today I'm representing iWelcome, a company where I work as an architect, and my name is Maciej Machulak. I'm also the vice chair of the UMA work group, working with Eve and others from the community on this quite an important standard, I would say. And the agenda is pretty straightforward. I would like to divide the entire masterclass into 3 separate sections. And the first one will be just a brief introduction. So I'm not sure. Could you just raise your hand if you heard about UMA, if you know what it actually is? Right. Okay. Okay. So who doesn't know anything about UMA? Okay. So this will be like a good intro, but also going into the details regarding the architecture and some of the things regarding the protocol. The second part will be mostly about the specification. So we'll go through the specs. There's a number of these that form the entire UMA concept. And during the third part, we will have two demos shown. The first one by Eve Mailer from ForgeRock, and the second one by Mike Schwartz from Glue. And each session is sort of self-contained, so if you feel like that's enough, you just learned everything you wanted to learn, then you can just skip the other sessions. And please don't hold the questions actually till the end. I would appreciate if you could ask if there's anything unclear during the presentation. I would like to be more maybe informal so that we can engage in a discussion. So in the first part, I'd like to present some of the problems that we saw when we started working on UMA. And I'd like to provide you with an overview about the architecture and also what are the relationships, what are the relations between different parties of the UMA architecture. I'll start with how sort of the data has been and is still actually being shared on the web. So, initially there was this classic model of, going to a website, disclosing some information. There are obvious problems with that. You provide the data, provision the data by hand because you just have to fill in all the details. You provide it by value, which means that if it changes, you have to, if your address changes, you have to go to all the places and update that. You overshare because, there's an entire set of data that has to be provided, so you just, fill in all the details before you click on submit. And you often lie because you just want to get to the service and, you're not really paying attention to what you're typing. And obviously, there are some other ways of getting the data into the service, but in the Web 2.0 era, then these sort of ways often require that you provided the password. So initially, a lot of services required you to provide a password and username, and these services would impersonate you and connect to a different application. And it could be a honeypot for the secrets that you had. But also, it was kind of a gray market because these integrations were not really, standard-based. They were proprietary. And then we had OAuth 1 initially, where, you could connect to different applications. The only thing is that you really had to provide this consent to the terms which were not your terms, and you may not have, had a chance to actually review them properly. And when you connected all and you created all these different relationships, then it resulted sort of in this messy access management because you had all your policies in all kinds of different locations on the web, and you would still overshare. With OAuth 2, again, it was a very similar concept, a different protocol. But we had still distributed and hard to follow management of security and privacy settings. For example, you would go to Facebook, you would see what kind of applications can get your data, what are the permissions for these applications. But you could also go to Twitter. Again, you could review the applications, see the permissions, and you would have to do that for every single authorization server that implemented the OAuth protocol. Of course, there are such websites as mypermissions.org. They just give you the link so you can go there and maybe review what kind of access settings have been made in the past, but they don't really solve the problem. And if we take a look at how data is shared between different parties, so if you want to share the trip information from one service with some other person, or if you want to share a document, or if you want to share some photos, then these are based on slightly different concepts. So we can use private URLs for that. They're very handy because you can just send it in an email, but they are very insecure. You don't know what happens with the data. They're really unsuitable for sensitive data. Well, you could maybe provide impersonation, so you could share your username and password, but again, it doesn't really solve the problem. Or maybe you can just implement an access management system, proprietary, not based on a standard like Google does. You can share information with other identities from Google. However, it's not standard-based. And now everyone talks about killing the password. So if we go in this direction, then sharing the password will no longer be applicable. And there are these things like NIMI, so you can have a band and authenticate with your heartbeat. There was apparently Google Trust API. Actually, it's something which I thought exists, but apparently it has been a project which got killed some time ago. And there's IoT as well. So all these devices that have to communicate in a very secure way. So it's a machine-to-machine communication. And these relationships, they have to be established, they have to be secured. And every single day, as Gartner says, nearly 6 million of these devices are being connected. But let's step back for a minute and let's again take a look at what happens when you just share the data, when you go to a website and you just provide some information. So you guys all know this agree button. You just provide the information, you have these terms, you click on agree and you share the data, not under your terms, but the website gets your information. You all know that probably that the amount of time that you would have to spend to read all the privacy policies and terms and conditions, that's a large amount of time. And in fact, people already know, and people from our industry already talk about the fact that terms and conditions are the biggest lie. And that's because, if your business model really relies on misleading the user, so if you don't give the users the required information about, your true intentions, how the data will be handled, if you obfuscate how much of the data is actually being collected, or if you're being opaque about a number of things that you do with the data, and with whom you share the data. Also, if you do not articulate properly how you gather the information, or you're not being clear about what you derive from that information, then you're really operating on a borrowed time. So this has to change. And it has to change also because users really do care about privacy. So it's no longer something that's an add-on. It's really something that should be built into every single service that we currently have online. It's obviously easiest to take a look at medical data, online medical data, and show that the privacy is way more important than the convenience. Some of the studies show that it's nearly 73% of people really perceive the privacy as way more important than the convenience of access to the data. And the same principle applies to virtually any other kind of information. There was this tweet that I saw yesterday from one of the colleagues. A lot of people think that some people, if they post information on the web, then they don't care about the privacy. But really young individuals and others think that privacy is really important. And by privacy, we don't mean it's secrecy. We really mean that it's selective sharing. So being able to share the specific amount of information that's needed for a particular service. So I think when we started working on UMA, in one of the first presentations, we already included this famous quote from Dr. Ankuvakian. And that's about what a really flexible user-centric identity management infrastructure should be. And you can take a look that it should allow the user to quickly determine what information will be revealed, to which parties, for what purposes, how trustworthy those parties are, and how they will handle the information, and what the consequences of sharing of that information will be. So privacy is really about the context, the control, choice, and respect. And in UMA, we talk about these four things we define these four things as following. So the context is the right moment where you make the decision that you would like to share the information. Control, because you should be given the ability to just define the specific amount of information that you'd like to share. The choice, you may want to share information on Thursday and you would like to maybe revoke that access on Friday. And respect, maybe you would like to actually share the data under your terms and you would like to expect other people to respect your preferences. So in UMA, we really would like to create this experience of having the ability to share information and from any application, not in a proprietary, but on a standards-based way, which is based on, which sort of resembles this universal share button. We really need, there's really a need for this also digital footprint control console where we are able to go and review how the information has been shared and who accesses it for what purposes. These are actually screenshots from one of the software that I've been working on where information is treated as the asset that you should have insight into. So you should be able to go and see what information is there in a distributed setting, how information is shared and accessed, etc. Obviously, this has to work across all your devices. And to address these problems, so to be able to provide the users with the necessary means that would allow them to share information in a very selective, in a very efficient way, that's where we started working on UMA. That's where we came with the UMA concept. So UMA defines, and that's, I think, the best definition, is it defines how resource owners can control protected resource access by clients which are operated by arbitrary requesting parties, which are other individuals or corporations, and where the resources reside on any number of resource servers, so they can be distributed, and where centralized authorization server governs access, and this access is governed based on the policies which are defined by the resource owner. The architecture is very, I would say, simple as well. The authorization server is the central part, which connects to a number of resource servers, which are web applications, and the clients, which are other web applications or mobile applications, if they would like to access protected resources from resource servers, they have to interact with the authorization server before they can get access. The resource owner is responsible for managing how the authorization server reacts to such access requests and provides this sort of, basically sets up the policies which dictate how the authorization server reacts. Requesting parties are the individual specific people or corporations that manage the clients, which is simply a software. So if we take a look at OAuth, and if we see that in the OAuth space, we have a resource server. It has a protected resource. We have a client which would like to get access to that resource. Then the authorization server is this component which manages the relationship between the client and the resource server, but it's really coupled with the resource server. So in OAuth, the AS and RS are really in the same domain. So as with Google, right? Google has their own authorization server, but it's really coupled with all the resource servers that Google provides. And UMA adds a clear separation. So the authorization server is yet another component which connects to one or many resource servers. And this authorization server manages relationships between clients, they were previously called requesters, and resource servers, which were previously called hosts. So initially, we wanted to change the way OAuth works, or add new, let's put it this way, features to OAuth. And we wanted to apply this privacy by design characteristics to data sharing, which is done with OAuth protocol. So the resource owner is really the user, which has the resources and manages access to these resources. And the resource server simply delegates authorization to a specialized component. So instead of managing that on its own, it talks to an authorization server, which provides a standardized API. And the standardized API allows this authorization server to act as an authorization as a service specifically. And the requesting party, which is not actually defined in OAuth, because in OAuth we have, it's actually the same entity. So the resource owner and the requesting party is the same person. But in UMA, these can be different. And if we think about the current identity federation solutions, you can see that there's this similarity. Basically, the resource server becomes a relying party, or similar to a relying party, while the authorization server is similar to the identity provider. And what are the policy types in UMA? You can share a resource with a specific person based on their identifier, but you don't have to stick to a particular maybe domain. You can just share it with someone who can prove that they have or they hold this particular email address. Or you can define a policy where you will request a promissory statement that someone, if they access your photos, they won't print them. Or you may require a third-party asserted claim that a person is over 18 years old or is a member of a particular university. But under the hood, it's still OAuth. So the authorization server and the resource server have a relationship which is established with the OAuth protocol. And the requesting party and actually, I'll show this. So the resource server and the authorization server have this relationship which is established as an OAuth relationship. There's a protection API token which dictates that the resource server can actually communicate with the authorization server. And the protection API that the authorization server provides, it just allows the authorization server to act as this component that defines how access is being, whether access, how resources are protected. And another OAuth instance that we have in UMA is actually the instance between the client and the authorization server. So there's a token which is called the authorization API token, which allows the client to talk to the authorization server for a specific purpose, to get a token which would allow this client to access a protected resource. So the protection API token and authorization API tokens are simply names for plain old OAuth tokens, but they represent a very important concept in UMA. So the protection API token represents the consent of the resource owner to federate authorization, so to externalize authorization from a resource server. And the authorization API token, it represents the ability for the client to talk to the authorization server and negotiate access. And it's really important to note that UMA does not care about does not care about the types of resources that are being protected. So anything that can be addressed with a URI can be protected, which means that the RS is really authoritative in terms of making sure that the verbs are as they are, and the object types are as they are. They can be all kinds of it. Can be personal information. It can be any information that, or it can be just an API, and it simply registers that information as a metadata with the authorization server. So one of the features of the authorization server is to get that information, which is then presented to the user, and the user can set a policy to dictate how access, whether access should be granted or not. And importantly, it can be a many-to-many relationship. So if I have an account on a resource server, then I can connect this resource server with my preferred authorization server. But someone else on the same resource server can connect it to yet another authorization server just because they like it more, because of the user interface or the set of features that it provides. We'll skip that, but the set of use cases that UMA addresses is quite broad. In the work group, we sort of paid a lot of attention to the use cases that we would like to address, and some of these use cases relate to specifically personal information, like just personal data or e-transcripts or patient-centric health data. But we also talked a lot about API security, and in the last part, in the third part of this masterclass, you will see two distinct implementations of UMA, one addressing personal information, one addressing API security. The implementations which are currently there, well, there's maybe not a large amount, but I would say a fair amount. All right, okay. So yeah, we have some open source, some closed source implementations of the protocol, or actually the set of protocols. And I'd like to just show you, how the protocol works in practice and explain all the things that we discussed on a very basic example. It's quite an old example, but I think it still shows the way the protocol works. And it's based on a use case where a student would like to share some information from one system to another. Before I do that, I'd like to ask if anyone has already seen the demo of the transcript of records sharing scenario. Okay, that's good. So the scenario is really simple. A student applies for a job position, and they interact with an online job application system, and they have to fill in a job application form. They have to provide some personal information, and they have to also send a verified document with their marks from the university. And in our scenario, we'll show that you can share that from the university directly, and the process will be secured with the UMA protocol. But we'll also show how some data is not transferred, but is required on the other side. So we will show that a person sitting on the job application portal would like to get some new information from the student, and they are able to request that information and get once a policy gets created. So to visualize the process, we'll have Peter, who will interact with these two systems: a personal data service, which is at a higher education institution, and Career Monster, which is a job application portal. Typically, what would happen is that student downloads some documents, they have them verified, and they upload these documents to another system. So there's no direct interaction between these two. And in the improved scenario where there's UMA involved, what happens is that Peter still manages the resources on the personal data service. The only thing is that when he goes to the job application portal, they simply select what information they would like to share, and that information gets transferred in a way that there's an underlying UMA system which makes sure that only the selected bits of information are shared for a specific purpose. So if we take a look at the UMA architecture, it looks like this. So the personal data service will be the resource server, and Career Monster will be the client. And I'll show two different settings. One where Peter, the student, will be acting both as the resource owner and the requesting party. And a second scenario where there will be a different requesting party. So there will be an employer, the person who actually posted the job position, and they will ask for some new data, and they will get access to the data. Right. Okay, so I'll be using two different browsers just to visualize the process. So this won't be a live demo, it's recorded. So in the Google Chrome browser, I'll be acting as Peter, and in Firefox, you see that I'm already logged in as Tom. Actually, I'll be using Google as my identity provider in this case. So let's start with Peter. I'll show the system that I'll be working with. So this is the personal data service, the Career Monster, and this is the UMA system, the UMA authorization server, which sits in the background. So initially, what I will do is that I will log in to the personal data service. So this login process is done with one of the proxies that we've built, and it allows the user to sign into an application, and the application immediately gets access to one of the tokens which is required for UMA. In this case, this is the Protection API token. So we sign in, and the application became a resource server at this point. You can see that what happens is that I simply have some data in here, so nothing unusual. There was some personal data. I now have my transcript of records. And because I'm a student looking for a job position, I see that there's an advertisement, and I go to the Career Monster application. Again, I log in with Google, and I see that there are two openings available. So I'd like to apply for actually both. You can see that I'll be applying for a Python developer position, and I'll be applying as Peter Smith cloudidentity@gmail.com. I have to provide some personal information like my names, and I also have to upload a transcript of records document. But what happened is that the system detected, and that's through a discovery process, that I'll stop that, that there is a personal data service which I'm connected to, and it has information of that particular type. So in this case, the name and the transcript of records document. And instead of providing this information by hand, I can import that directly from the system of my choice. Just before I apply for the job position, there's one important thing. Once I transfer the information from one system to another, within the context of Career Monster, it will be shared with Tom, the employer, the person that actually posted that job position. So now I'll show that I won't be filling in those details in a manual way. Instead, I'll select the import from personal data service, and I get redirected to a page which resembles an OAuth authorization page, but clearly is a bit different. I'm already logged in because during the login to the application, I was already signed to, I got signed into the authorization server. And the page actually says that Career Monster will be given access to my full name, which is owned by me and stored at the PDS. I can see that I'll be granting a read type permission. because the application only asks for the read permission. I click on continue, and at that point, a policy gets created, and the data can be transferred from one application to another. I do the same thing for the grades, so I import my transcript of records document. I end up on the very similar page. I see that the transcript of records document will be shared. I see that it's a read type permission, and I click on continue. A policy gets created, the data gets transferred, and if I apply, the data within the context of Career Monster will be shared with another individual. If I apply for the Java developer position, then if I click on import, the policy has already been created, which means that the data can now be easily transferred, and there's no need to make an authorization again. Are there any questions so far for that flow? Yeah?
How much does UMA go into defining the structure of the personal data store?
It does not care basically about the types of information, as I mentioned earlier. So you could, for example, register a profile or an individual name or a collection of names. So there's no restriction on how the data would be exposed by a PDS.
Effectively, any resource server is authoritative for
Yeah.
its own API.
Precisely. Yeah.
Would it be possible, you had two different sharing requests that you went through?
Yeah.
Where you shared the first name and the transcript. Would it be possible to do that in one step?
Yes. So it will be possible, and this was just to show that the policy gets created for the purpose of the second application. But yes, it would be possible, but only in the current spec only if this would be exposed as a single resource. So if we don't have the ability to register two resources at the same time, permission for two resources at the same time. Oh, sure. No, so it wouldn't be possible if these were two different API calls to the resource server. So UMA requires that for each API call, there's a registration of a permission which has to be authorized. So in short, if that information is exposed, for example, as a job application profile, which includes a name and a transcript of records, then yes, it would be possible in one step. But if these are two different resources, then no.
If you had first name, last name, address, would those would have to be grouped as one?
Yes, precisely. Yeah.
That's helpful.
Yes.
Depends on how you do the resource set and how you do your scopes, actually.
Yeah, but but precisely that's what I'm saying is that if they're registered as a collection, then it is possible. Sure.
Each API call needs to map to a separate user interface interaction for approval?
No. It's basically during the API call, for example, for the name, right? If I would like to share the name from one system to another, then it would result in the registration of a particular permission, most likely for that name. If the resource server is able, and that's what Yves was saying, is that if the resource server could, for example, detect that the call might refer to a bigger profile, and it would register at the authorization server a profile which would include a number of resources, then every additional API call within that group of resources would not result in this user interaction.
Think of like OpenID Connect and the scopes that it's defined. It's defined a number of scopes, and some of them overlap each other. So if you were to UMA protect a user info type endpoint, you could design the scopes just like that and get the exact same result.
Yeah.
I noticed in the demo, the resource owner, the
Yes, yes.
Is that a requirement?
No. No, that's not a requirement. I could, it's also shown just for simplification purposes, just to show the demo and not focus on the authentication. But the UMA itself is a little bit more complex. Like if I logged in to the one system, you've seen that I haven't done any additional steps for the UMA to work. Normally what would happen is that if I log into a personal data service, I have to select explicitly the authorization server which I would like to use for that service, and I have to go through yet another flow. So some things which are shown are just for simplicity purposes. Right. So let's just take a look at what happened in the background. Or actually, no, I think that right now I'll just present the second scenario, and then we'll take a look at what happened in the background. So let's switch to a different browser. We are now acting as the employer. The employer got information that there were some applications for the job positions that the employer posted. They just log in to the Career Monster application. They go to the employer portal, and they see the two applications from Peter. So you can see that the name is Peter. That's the email address, and these are the grades. The only thing that's missing is the phone number information, and we would like to import that data. So what we do is that we simply click on Import Additional Data, and we get redirected to an UMA authorization server. In this case, however, we're not allowed to, you can see that I'm logged in as Tom, but I'm not allowed to authorize access because that's not my data. Again, that's an old user interface, but it has all the necessary elements. It shows that the Career Monster is requesting access to phone number, but owned by Peter and stored at a PDS. And would you like to request access to the data? If we click on Continue, access request gets submitted, but no data is shared. So no policy gets created. We have to actually go back to the student, and the student explicitly has to go to an UMA system, but maybe they could get a notification on their mobile, and they see that Tom Smith from Career Monster requested access to phone number information which is stored at a PDS. Do you want to grant access? We select the read access, we click on confirm, and in this particular case, the policy gets created, which means that if we switch to Tom and if we click on import, the phone number can be transferred because there's already an established authorization. Just to show the policy is already in place, you can see that if we do the same thing for another application, then, for another job application, then the data gets transferred. So let's review these processes, the establishment of the policy, transfer of the data, etc. Let's take a look at the at the history and go step by step. So the first two entries, the PDS and the Career Monster, have these entries like a system obtained access token. And this is what I've done at Cloud Identities, that we integrated UMA with the Identity Federation protocol, where the user, when they signed in, they would also get the ability to, the application would also get the ability not only to get some information about the user, but also a token for the user's preferred authorization server. But then what happened is that when I logged into Career Monster and I wanted to transfer my full name, and I clicked on Continue, this is where the policy got created. So I added Career Monster to the sharing settings of full name, but then I accessed the full name. So these are two different steps. The same for the transcript of records document. I added the application to the sharing settings, but then I access the transcript of records document. And then every single request has this entry of being simply accessed. There's also the entry when Tom requested access and I granted access for Tom. So I simply added Tom with the restriction that he can only use the Career Monster application to sharing settings of phone number. And then Tom made 2 API calls. Basically, his application made 2 API calls to Career Monster, to the PDS service to get the data. So if we take a look at what information is currently existing, is that you can see that it's a phone number, full name, and these are all defined by the resource server. So the authorization server does not care what these resources are. And this is the information that is actually registered. So it's a name, identifier, some set ID, a URI, which is actually the location of the resource. So this is the endpoint specifically, the icon, and the scopes as well. The scopes, so the available permissions for a particular resource. And in our implementation, what we had is that we had this myself and others type policy. Myself was, what are the authorized applications acting on my behalf that can access a specific resource? So I can change the permissions, add a new application if I want to. But there's also an others type policy. For the full name, you see that, I haven't authorized within the context of the authorization server other people. But for the phone number, if I go to myself, there are no authorized applications because I haven't done transfer on my behalf. I authorized Tom, and I authorized him for specifically one application to get read type access. So you can see that I can add new applications if this is what is required. Obviously, I can take a look at the history of a resource, so how it has been managed, when it's been registered by the resource server at the authorization server, how the policy changed over time, what are the accesses, what were the accesses to the resource, etc. So for example, in here, I can clearly see the entry which showed that Tom has been added. And I can also go and see Tom as a contact, and I can see what kind of resources, distributed resources, he has access to. And I can review the history, when he was added to a particular policy, when he was removed from a particular policy. I can also go and select an application, go, for example, review what kind of data can Career Monster access. So it can access my full name, my transcript of records, and the phone number. The only thing is that the first 2 resources can be accessed when the Career Monster is acting on my behalf, and the third resource when it's acting on behalf of Tom. Are there any questions on the demo before I move to the next slide? Yeah?
Can the resource server, when registering its resources with the authorization server, provide advanced descriptions and additional explanations about what the resources are? Like just the name and URI might be enough to explain to the user?
Yeah, so the name and URI are not the only fields that the resource server registers. So typically what gets registered is like a description and something which is meaningful to the user when setting up a policy, but also an icon. So something that can be displayed by the authorization server so that it looks better when a policy gets created. Again, that's an old demo, so a lot of icons are the same, but yes?
Support collection of resources or users or actions
I didn't hear the beginning of the question.
Supporting collections, like for example, in Facebook, for example, share with friends,
Yeah.
share with family, like Google Plus, all kind of collections. And I want to share album, not picture by picture.
Yeah, I mean, that's definitely possible. But some of what you described is a part of the authorization server functionality, which is outside of the scope of UMA, and some is within the scope. So, for example, sharing, not a single picture, but an entire album, that's something that UMA allows because the resource server registers a resource set which includes a collection of, for example, photos. The way that the policy is set at the authorization server, that's totally outside of the UMA protocol, and that's something which the authorization server simply provides as an add-on. So in our case, you could only share with individuals, but if you had the functionality where you could group these, then you could share with a group. Yes?
In the demo, you had a use case where the requester sent a request for additional information,
Yeah.
phone number. Is there a way that that request can have additional metadata with it so that the resource owner has some context about who the requester is? And second question, is there a way that they can then authenticate the requester?
So regarding the first question, we had this. We had in the demo, for example, just a text field that would allow the requesting party to provide information why I actually need the data. So there was no standardized sort of purpose for which the data is being collected, and but that was good enough. So it was for our purpose just to display that information to the user when the user was about to set a policy. And to authenticate, well, what we do in the current implementation is that the user is already authenticated at the AS. So that's why what gets displayed in this notification setting is that this particular user is requesting access, and we trust the AS that the user got authenticated. But the policies which were shown on one of the earlier slides easily allow you to say that, or you could tick a box that, hey, actually this guy has to authenticate with a two-factor authentication or something like that. I'm not sure if this is what you were asking for.
I'm thinking maybe like a use case where it's a medical health record, and maybe it's another physician that said,
Right.
I need more data. You may not have had a previous relationship with this other physician, so you want to vet them, make sure it is a legit physician.
Right.
How would you go about doing that if you didn't have a prior relationship?
Couple thoughts about that, if I may.
Sure.
So I think exactly what you said is, I mean, it's true in my case as well, because we've thought about this as well. There's a lot of extensibility in the protocol. So currently in the protocol, there's no way to accompany what essentially is a client hitting a resource without a token. There's no way in that to accompany it with anything official, but there's extensibility to accompany it. There's also, I mean, UMA is essentially, in the general case, an asynchronous grant flow. So what that's doing is it's hitting the resource without a token, and then the resource owner has an opportunity then to set a policy if they wish. So then what could unroll afterwards is a policy that requires some things of the client and the requesting party, which could include essentially some purpose of use limitation type stuff, which you could do in a claim, and you'll get into details about claims as part of trust elevation in a bit. That's what I think you're thinking about, probably purpose of use.
Yeah. Thank you.
Treatment, payment, operations type, yeah, okay.
Good. Yeah.
The way you responded to the earlier question about connection, it sounded like you were saying it depends on authorization service versus
No,
Is authorization service assumed to be OAuth authorization service, or is it OAuth?
UMA authorization service, but when I said collections of subjects, so in terms of collections of objects, like that's a resource server's job to describe that properly to the authorization server. So for example, register a set of, I don't know, photos. Or Yeah.
So when the resource server makes resources available to UMA server,
UMA authorization server.
the UMA authorization server, does that preclude that resource server from accepting tokens from other issuers that are not that UMA server?
No. That's like the resource server and the authorization server, that's a many-to-many relationship. So if you, like in the most flexible way, each resource can be registered with a different, each resource even owned by the same individual could be registered with a different authorization server. So it's the job of the resource server to, it will be covered in the second part of the talk, but it's job of the resource server to specifically be able to say that this resource, this specific resource is being hit, and I have to know what's the resource owner because I have to get their protection API token. I have to know which authorization server protects this specific resource, and that's where I'm going to ask, is actually the access good enough? Is the client good enough to get that resource? Yes?
Does the UMA include standards of how the resource owner can review over policies that has been granted in the past and then maybe
No.
evolve the policy?
No.
Is there any standardization around the naming of resources?
About what, sorry?
Around the naming of resources.
Naming, no.
So you may,
Yes.
right, there could be conflict between phone number.
Yes, yeah. So the way in our implementation, we just came up with a schema for our set of resources, and what we did is that we would allow the client to do simple discovery. I need a name, and there was basically each single type would have a unique identifier. So, but there's no work like this being currently done. It's quite important, but I'm not sure if we started actually the discovery discussion in the UMA group, not yet probably. So still something that has to be addressed. Yes?
Maybe you covered this in the second part, but does resource server tell the client where authorization server is?
Yes. It will be covered in the second part as well. So this will be more technical, more technical details, and you will see the flow of messages as well. And I think we actually should be having a short break right now, but just to summarize very briefly. So UMA, it's a protocol for lightweight access control. It's a profile and an application of the OO framework, and it's a set of APIs, the authorization API for the clients, the privacy and consent APIs for the resource servers. But also it's a Kantara initiative work group, so if you would like to contribute, then you're more than welcome. And it's already made up of 2 recommendations/standards. So just end of last year, version 1.0.1 has been released.